All right, you guys, so that last video I think ended here, right? All right, so let's start with number 2, make a substitution. I also like to call this double log because double log means double exponential, right, in order to solve it. So basically, the one way you can do a substitution, you could do like a t substitution if you want to. I almost think it's easier to just do a double exponential. All right, so basically what we're going to do, this is natural log, so that means my base is e. So I'm going to start by switching forms, which means I put e to the exponent of 2 equals this whole argument, ln of x. And then guess what? I do that exact same thing again. So this is base e. I raise it to this exponent, e squared. You see that's my double exponential, e to the second. And then that equals that argument. And I'm done. I solve for x. Right? So it's just like a double switching formats. E to the e squared would be your final answer for this one. So same idea with letter B. Okay, so start outside here. So you take the 3, that comes down as your base. Exponent is -2, and that equals this whole argument, log base 3 of 2x. And now you just do it again. Base is 3. Exponent is this whole thing, 3 to the -2, there's your double exponent, equals that whole argument, 2x. Now I'm still not done, I have to divide by 2 to solve for x in this case. And you can actually simplify a little bit. 3 to the -2 is 1 over 9, right? So this technically would be x equals 3 to the 1/9 over 2. Now 3 to the 1/9 is also known as the 9th root of 3. So I would take either of these answers for your final answer there. Okay, so that's a double log. Again, if you see double log, it's going to become double exponential, and then you just go from there. All right, so part 3, what if there's one log on each side? So if you notice you've got a log and they have the same bases on each side, log base 5, and there's one log on each side. If there's 2 on one side and 1 on the other, you can't do this. But if there's one log on each side, then since they're the same bases, you can basically get rid of those 2 logs and just set the arguments equal, right? Because if the logs are the same, then the arguments have to be the same, right? These are equal. The left-hand side has to equal the right-hand side. And so then I would just solve this and get my answer and make sure you're checking. Remember, we always have to check. Ooh, whoops, I didn't check on that last one. I think those both work, though, because they're positive. So let's go back up real fast and remember to check. So e to the e squared is definitely a positive number. When I plug that back in up here for x, it would just be natural log of e to the e squared, so that would work. And then same for this one. When I take this answer and plug it in here, times it by 2, the 2's would disappear. It would just be the 3rd root of 9, which is a positive argument as well. Okay, so let's try this one though. When I now take this -1/2 and plug it in here, I notice I get 3 times -1/2, which is -3/2, which means that that argument is not greater than 0, and so this does not work, and we actually get no solution. This is an extraneous solution. So that's why you got to check. Okay. For letter B, same idea. Those logs are the same, so I can get rid of them. Set my arguments equal. This one now gives me a quadratic. Bring everything to one side. Factor. Okay, and now let's see, do both of those work? So if I take 4 and plug it in here, 4 squared, yep, that's good. 3 times 4 is 12 plus 4. Okay, we're good. How about -1? -1 squared is positive, so we're good. -1 times 3 is -3, plus 4 is +1, so we're good with that one as well. Okay, so just check to make sure. Again, you're checking to make sure that the argument is positive. It's not that the answer has to be positive. So like this answer, -1, that's not a positive number, but it doesn't matter if the answer is positive. What matters is that the argument is positive after you plug that back in. Okay, so these ones both worked. All right, the last type of log problems are ones where you're using the log properties, okay? So this one has a couple ways you can solve it for A. The first thing I noticed that those are both same bases, so it might be easier, well, and there's so many ways to do this, but the property on the left, let's talk about that. It's 7 raised to log base 7, so our property tells us that's just 2x, and then I can just solve this. So again, just using those properties. On letter B, we see on the left-hand side of the equation we have 2 logs that are being added. So this is where I'm going to condense by using addition. I'm sorry, by using multiplication, because addition turns into multiplication. Then I'm going to rewrite this. So now I've got just 1 log equal to a number, so I can now rewrite this as, an exponential. So 3 to the first. I'll go ahead and distribute that out. And so then I get a quadratic. Hopefully this factors. And so x equals -3 and x equals 1. I still have to check, okay? So I'm going to go ahead and take this -3 and plug it back in. Right away I notice, boom, that's going to give me a -3 there, so that one does not work. How about 1? 1 works here. 1 plus 2 is 3. That one works. So I have 1 extraneous and 1 good one. All right, with letter C, we've got log base 10 of x minus 2, no parentheses. So, right, that's really saying it's this whole thing, and then the -2 after it. So what I want to do here, and then I've got a log, so I've got this extra, like, -2 here. So what I want to do is I want to bring all the logs to one side, and then the numbers to the other side. So what I would do is I would bring this 2 over here, and then move this log by subtracting it. So what I end up having here is log, I'm not going to write the base because this is base 10. Okay, so now I just got log of x minus 2 is just equal to 2. Now what I can do is use my property, condense. This is subtraction, so it's going to condense into division. This is, again, base 10, so now I rewrite it as 10 to the 2nd power equals x over x minus 2. So we can solve this. 100 times x minus 2, 100x minus 200. So x equals 200 over 99. Let's check and see if that works. So you always plug back into the original. So for that first one, it's good. When I plug it back in here, 200 over 99 minus 2, that just barely works, right? That is a positive number, so we're good. So this is just a little bit bigger than 1, or sorry, just a little bit bigger than 2, so we're good. All right, for D, we've got natural log of x plus natural log of x plus 2 equals natural log of 15. There's lots of natural logs. So first thing you want to do is condense on the left, and I get natural log of x times x plus 2, because addition becomes multiplication. And now notice I've got a log equal a log, so I can use our trick of getting rid of those logs and just setting those arguments equal. I went ahead and distributed, and I can factor. So 2 answers. Don't forget to check them. Right away I notice when I plug in a -5 to this first one, it does not work. But let's try 3 is good there, 3 is good there. Well, there's nowhere else. So we just have 1 answer on this one. I know I went through those very quickly, so that's why it's a video. You can and should pause, rewind, copy again, go back and double check that this makes sense. But those are your log equations. The biggest thing to remember anytime there's a log, you have to check your answer, making sure that your argument is always positive. All right, you guys, head back to the calendar to find out what your homework is, and I will see you soon.